to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello and welcome to another meeting of the Digital Signal Processing C++ JUCE study group. I got the order wrong. It's the C++ Digital Signal Processing JUCE. Who cares? We don't even do JUCE anymore. How are you all doing?
I'm doing fine, thank you.
Very good.
How are you?
At least we are doing some C++.
We are doing some C++. Yes, we have been doing C++ consistently over some months now. And I'm happy about this because we took some detours in other languages and technologies. We are circling back. Alrighty then. So, Cwits, you were making noises in the pre-call. What's that about?
That's my progress for the past couple months that I made it is, you can hear it. Yay. Wait a second. So, I will do this thing. 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 Now I'm building my personal digital audio station, workstation.
All right.
So we're still talking about the same project. It's the Raspberry Pi and the Ableton Push and that whole issue with the analog to digital converter or digital to analog. No, it was the analog to digital converter. Am I right?
Yes.
Okay.
Oh.
I wonder if I can make you full screen. No.
I don't know how to disable microphone from my. Oh, it should be good.
Okay. Isn't C supposed to make it full screen? No.
I don't know how to make him full screen, but I can do something for the stream that makes his screen bigger. It's a hack, but people on YouTube will be able to see him slightly bigger, and I can also see him slightly bigger.
How I should hold my phone like this or like this?
The other way.
This way, yeah?
Awesome, yeah.
Okay. So, I don't know where to start and what to tell. Shut these things down. Let's add a new track. For example, put some music there. Oh, too loud, yeah? Sorry. So it is playing, yeah? Nothing fun, nothing interesting, nothing fun.
Hang on, that already is very interesting. To recap, what you have there is software that you wrote that is running in the Ableton Push, and the Ableton Push itself is playing the samples. Are the samples in the Ableton Push, or is this just controlling the Raspberry Pi?
Oh, it is coming from this piece of mess, and under that PCB, green PCB is Raspberry Pi, and every sound processing happens there. No, not right here, but there.
Okay.
And the most interesting thing, at least for me, I have a small microphone here. The something I didn't make that it's showing while it's recording, but it's recording.
So cool.
The something I did. Yay! Yay! That's my progress.
That's awesome. And when you're recording, I suppose there will be many timing issues. Am I right?
What kind of timing issue?
Well, the same kind of timing issue you had to solve for the MIDI stuff.
I used the same code. I'm not rewriting the whole thing, but like I don't know how to explain.
How do you sync the clock with the clock in the analog to digital converter?
Sorry?
I suppose there is some kind of internal clock in the analog to digital converter, and that whatever you are using to record, probably the Raspberry Pi, needs to sync the clock with the external device.
Okay. I got it here. Let's see if my wire from microphone is long enough to reach this. So the thing is, the microphone is coming here, yeah, and I'm grabbing audio from here, and this going to the analog to digital converter, and then it goes to the Raspberry Pi that is. But everything is clocking from the STM32 microcontroller as I wanted previously, and I figure out how to make it, how to put it together. So the analog to digital converter and digital to analog converter are syncing, and Raspberry Pi as well are syncing from this little guy, and everything works.
So that is the microcontroller, that is the heart of the operation. And then the little boards that are the ADC and DAC, they are just bog standard ADC and DACs you got from AliExpress?
Yeah. As well
Nice.
as this microcontroller are from AliExpress too.
Of course. And then the thing below that we see is just the guts of the Audient ID14. Am I right?
Yes.
That you're using for the preamp section only.
For which?
For the preamp section, because you're not using the ADC in that, right?
PM? What is PM section?
The preamplifier for the microphone.
Okay. Yes, I'm using only this part, this top PCB for the amplifying microphone sound from the microphone, of course, and then it goes straightly to the audio to digital converter. And there is some powers that is, here is 12 volts, and I don't remember where, here or somewhere here maybe is bipolar 6.3 plus minus power for.
And you used this many months ago. You showed us some schematics for this board, and that's how you figured out how you needed to tap into the circuit, or did you do any sort of investigation by yourself there?
I can switch to my PC and turn on the camera, because all the fancy stuff is here. I showed already. Maybe. So, sorry, what was the question again?
I'm asking about how you knew where you needed to tap into the Audient ID14 to get a hold of the pre-amplified signal that you routed into your ADC, for instance. Did you use the schematic that you showed us a couple months ago, or did you probe the board and found the place?
Of course, I used the schematics. Wait a second, I will share my screen. Which one? General. I don't know how to get rid of this small window. Sorry. No, there was different schematic. Wait a second. Oh, this one. Yes? No? Oh, not this one. This one?
It was the other one after all?
There is a lot of schematics, and basically here is XLR inputs that's going to the upper board. Let's try to find. Oh, I'm so stupid. Yeah. Because I looked here and didn't saw this part of the schematic.
Okay.
So yeah, basically it comes from this connector to the inputs, and then the magic happens here, and I'm just taking this ADC plus output of the schematic of that top board that is come back to the same.
Okay, so the circuit that we saw there is the guts of the preamplifier section.
Yeah,
IG14.
basically things that are here. I assume that the direct input also will be working as well. I'm not sure, but maybe it is connected with I assume with first input, so I think it will be working as well.
All right, now that this is working, I'm very happy for you. I know how much work it was for you to get all this to work, and how many dead bodies did you have? How many boards did you burn along the way? Chips?
Only one, by the way. If you remember, I was showing on the one stream the burnout microcontroller, bigger one than I'm using right now. But yeah,
that's a great body count. Congratulations.
Yeah, I think that it's not bad. But to be honest, I was struggling if it would be enough only positive signal for my audio to digital converter, because there is positive and negative, but it is using by internal analog to digital converter. Yeah.
And you look into the voltage range that this circuit outputs, and did you have to do any work to match that voltage range in the ADC? Because it could be the case that the ADC in the audience used more voltage or less voltage, and then you would need to compensate for that before you replace the ADC. Am I right?
I assume that yes, you're right, but to be honest, I didn't do any math. I just plugged everything together, soldered, and hope that everything will work fine.
Awesome.
But to be honest, there is a pot that you can regulate the input volume, so it can be adjusted.
Of course, yes.
But to be honest, ADC can perfectly handle overdrive.
That's the spirit.
Rock and roll, man. Awesome. So now you can record, playback. You have multiple tracks. And I suppose you have some other effects as well.
No, I don't have any effects right now. I even didn't recreate the sampler that I had in my previous version. But I just want to make it slightly different, and I want to achieve the how to say it. Don't look at my version of Reaper, please.
If it's not broken.
I want to achieve something similar that all other DAWs offer as well, about any effects. Like, I don't want to compile them together with my like project, but I want to make them separately so you can just, I don't know how to tell that. Don't based on monolith.
So you would do some dynamic loading of effects.
Yeah, but I didn't get too far with that. Like previously, sorry, where is there? Those effects, that simple filter and oscillator was in the together with all other files, yes, like and the sampler as well. But I want to separate them somehow. I don't know how yet. Didn't do much investigation about that. Was doing other things, but I will get to it soon somehow.
I have, I guess, a C++ question for you then. The disadvantage of separating the effects into their own modules and dynamic loading are pretty evident to me. The disadvantages are it is more architectural work. You will have to compile things separately. You'll have to ship all the dynamic libraries. You'll have to do some dynamic loading, which is more complicated. You have to pass more flags into more compiler instances. But I'm not sure what the advantages would be. Apart from, of course, letting other people develop modules for your project, which is like what VST and audio units do. But for your own effects, the internal effects, the effects that ship with your software, what is the advantage of having that modularity, of breaking things apart into separate libraries?
The first one is because it's fancy. No?
Okay.
How to enable the folder view? I don't remember. Sorry. But folders. Yes. But the other thing is that I want to implement at least LV2 support, and maybe in the future VST as well, but in late future somewhere LV2 will be ready, and it is requiring dynamic loading as well.
Yeah.
For example, LMMS have this thing, they can compile plugins separately, and I'm inspiring from here, but it is very difficult to find the traces and, and everything. I don't know, just it's so cool, I think.
Okay. Yeah, I always wonder why people made these architectural decisions. Even in Reaper, the internal effects like recomp and req, they are VST, so to speak. They are dynamically loaded, and I never really understood what was the point.
To be honest, I don't know what is the point of that.
Yeah, because it's not like it would be very fun if we could just take the Reaper effects and use them elsewhere. And yeah, one can use the very old re-plugs in Windows machines, but generally it's not something you can do. You cannot just load recomp anywhere in macOS or newer versions of recomp. So if you cannot load the plugins elsewhere, and I don't think they ever update the plugins without updating Reaper as well, they are already coupled. Why bother with external libraries? I'm a fan of big monoliths. I'm wary of abstractions generally.
In my opinion, it is easier to develop them because you are, at least you don't have to recompile the whole project when you're writing the code and do some tests and prototyping.
That is a good point.
Because even now for me it takes much longer than I would like to if for example, if I change something in this header, yes, on slide, I don't know, even if I don't add, yeah, it takes long list of the dependency that should be recompiled. And in that case, maybe it is easier and faster. As well, other people can do something.
Fair enough, fair enough. That's a good argument.
How big is that project? How many lines of code? Have you counted them?
I don't know, to be honest.
There's a lot of different files.
It seems massive to me, yeah.
Yeah.
I think it is, and it's still compiling. Like, I think it is smaller than this one. At least it looks like there is more files, but I still didn't implement some features from all projects. For example, there is no any MIDI processing right now, because I was focusing more on audio stuff, and I just didn't do that. Like there is only audio processing, but I will add in the future, of course, no worries. Everything will be there.
At some point you had some MIDI going, I remember that.
Yeah. And I was, couple days I was trying to, I even have MIDI files here, and I can load MIDI and it will be drawing on the display, but there will be no any effect. Nothing will be. And I don't know why, but this code reads the MIDI in the wrong way somehow. I don't know why. It was working previously, but now it is working properly. So I have to modify it. I even don't know how.
Tail is saying something here on the chat that I find interesting. By the way, hi Tail. And what he's saying is that DLLs, the libraries, aren't loaded until you need them. So if you don't use an effect, they won't be loaded at all, which I can appreciate. That's a nice thing. Is it a significant difference though? Loading, in this case, I'm thinking of Reaper. So loading the entirety of Reaper and not loading ReEQ and Recomp and the other 12 plugins, does it make a significant difference in loading time? I don't think it would. Of course, if you count all the external effects, and if you were to try and load all of them, all the VSTs, that's not a tractable thing. But I'm just thinking of the internal effects. Like if I am developing a DAW like Cwits is doing, my intuition would be to try and make all the effects internal and have a single binary. I wonder if that would make a significant difference in loading time or performance in any way.
Maybe it comes from the old computers when the processors wasn't so powerful and the whole things was loading slower and taking more time to. Maybe from there it was dynamic. And another benefit of that, at least in Reaper, I don't know about other DAWs, that if you have some broken plugin, it won't be loaded and it won't affect any program. How to say that? Sorry, I don't know that word.
Well, it actually depends. In my experience, if the plugin fails to load, as in there is some bug, well, not even that actually. I was gonna say if there is some kind of bug in. Oh, hi, Fotis. How are you doing?
Hey, Fotis. Good.
Great to see you. So if I was gonna say that if the plugin crashes while loading, it will not crash the whole DAW, but not even that is true. If a plugin crashes in Reaper and in every other DAW I know, it's gonna crash the whole thing. Unless it's Reaper and it's running the effect in a separate process, which is something that you can do, but you most often don't do unless you need some sort of Rosetta compatibility or whatnot. So yeah, for the most part, the plugins do have the capability of crashing the whole DAW. My plugins do anyway.
As far as I know, when the DAW is loading at this point, it is checking all the plugins that are available for the DAW if it can run them.
Isn't it for the project that it's checking when it's booting?
No, I think the Reaper does a scan when it's loading, and it tries to scan every plugin.
Right.
But that's a different kind of invocation. It's not instantiating the plugin. It's doing some sort of pre-flight check, I suppose.
I just checked the size of Reaper, the XE on PC. It's 15 megs, so it can't be that many effects. Does that include all the native effects, retune, etc., etc.?
If I understand this correctly, I think that executable is like a zip file in a way. So
Oh,
yeah, it kind of expands, decompresses into a lot more stuff and around 100 megabytes of stuff. And
I see.
even then, recomp and req and all the other friends must be like 1 megabyte. I don't know, but it probably is very small.
All right. Tail says, was this the one that you read? DLL aren't loaded until you need them. So if you never use req, then they won't be loaded at all.
Yep. Cwits, what are we looking at right now? It's a plugin factory.
LMMS DAW.
Okay.
LMMS DAW plugin factory, and this is the step when application discover plugin, as the name of the function. And I'm trying to find if plugin are instantiated or not. So
remember how 10 minutes ago I was saying that I am usually avoidant of abstractions? Anytime I see anything factory, I get shivers. Anything factory. It reminds me of Java beans and dependency injection. Jeez.
okay, then I have a question: how to name the thing, the class that stores all the file references?
All the file references.
Like I have in my project, I have a class called file factory.
Oh.
It's ideas stolen from the.
Is my comment hitting too close to home now?
This is stolen from not LMMS, but Qtractor, I assume. That was file factory. Then from LMMS. Okay, but and file factory, like when I'm loading any kind of file, yeah, audio or MIDI, doesn't matter. File factory like owns the file and give only references to another parts of the program.
Mm-hmm.
So the question, how this class should be named then?
I think the file factory is an appropriate name.
Yeah, that's the thing.
Yeah. I would probably find another thing that is equally generic and scary, like file manager. But yeah, the spirit is the same. Very generic, not descriptive. And yeah, it is what it is. I cannot think of a better name for it.
Me either. So I think just file factory describes it in the best way.
Fair enough. But are you aware that in the Java community, factories are a thing that are a big deal? Or were a big deal back when I was writing Java more frequently. And there were layers and layers of abstraction, and you would try to find where an object was instantiated, and it would take an afternoon.
I've heard some rumors about this thing.
It is true, yeah.
And I assume that all those things comes from Java.
But it is much better these days. It is definitely changed.
To be honest, I don't see here any kind of instantiation of the plugin.
And Tail has a follow-up. For what it's worth, not all plugin formats support scanning. So then the plugins probably are instantiated while scanning. Interesting. So it could be the case that a defective plugin could crash while it's trying to be scanned, unless while scanning the instantiation happens on a sub-process. And then Reaper could monitor the sub-process. That would probably be smarter, because you don't want Reaper crashing as it's scanning. I think that would be bad form. So that's why Reaper checks things like file date and time. Okay. That is also much cheaper to check.
What is Q library?
It's probably something related to Qt. I saw some other comment somewhere. So probably LMMS is using Qt.
And here is the line. Library load. Is it about plugin or not? File absolute path. I don't know, to be honest. Difficult to understand. This one 6 for the plugin entry point.
Yeah, we would have to dig into what is the implementation of the load method in the Q library class.
Plugin name. Here. This thing looks for this one. Okay. Return new audio effect. And what makes so difficult?
See, you're trying to see if an object is instantiated and it can take the whole afternoon. And that's what I'm talking about, abstractions.
But
they're necessary ones in this case.
Qtractor is way more easier than LMMS to understand. There is less abstractions and it's like more straightforward.
Good to know, good to know. All right, so moving on from that, what else do you have for us, Cwits?
I think that's all.
Okay then, all right. Yeah.
At least for me, it was a lot to do.
Oh, I am thrilled to have seen you recording and playing back and echoing. It was very rock and roll, and we all know how much work it was to get everything working and ordering the parts again and again and waiting for them and all the frustration that entails. So congratulations, I'm very happy.
Yeah, thank you.
Congratulations.
Guys.
Good work.
Fotis suddenly miss everything fun. But yeah, that's.
Did I miss something?
Yes, you did. You have to watch it back.
You will have to watch it back.
Sorry.
So yeah, that's my update for today.
And do you know what you want to do for next time?
There was a couple things, but I don't remember it right now what I want to do. I was fascinating about our stream because I was not lonely, but wait a second.
Okay.
Missed our conversations.
Oh yeah, all of us did. All right. Okay. So, Bo, what do you have for us? What have you been up to?
Oh, I have nothing.
That is not true. That is not true.
You always have something.
I have seen it firsthand.
You actually did say something in our Discord group about something you were working on.
We saw some photos on our Discord group where you, Bo, and Leandro was programming something.
Yeah.
Yeah, we did check some code. We did. We checked the Revolver compressor, didn't we?
Oh, yeah.
Yes, we
was
did.
that the one you were thinking about, Leandro?
Yeah. And
That's
not only
so
that, you
stuff.
showed me the whole folder you have of stuff, and the names are great.
Yeah, that's the best part. The naming. That's where the.
I really think that that's how you operate. You come up with a great idea for a name, and then you have to build something around it.
Yeah, kind of. Have I talked about Revolver before? I've been working on it for years.
Yeah, I know of it, but I think that we deserve a refresher. So how about you show us Revolver? And I was listening to it on laptop speakers in the middle of a burger place. So not ideal listening conditions. So how about you give us some samples of it working on, I guess it was drums that we had.
Sure. I'm gonna need to set up a project, but that should.
Would you rather have us switch to Fotis and then you set things up?
Yeah, so I can set up a drum track and show you Revolver. Yeah, I could.
Awesome.
I could show you Revolver. Yeah,
Okay.
Sure. Go ahead,
Cool.
Fotis.
One
So,
sec,
hi,
I'm
Fotis.
gonna...
Hello.
Oh, God. No, I have to set up something as well. Give me 1 second, please.
Oh, if you want more time,
no.
then I can go.
Make it 5 seconds.
Yeah, sure. Go ahead.
Let's see. You're not gonna believe this, but I'm actually editing XML as we speak. So I have 4 new stuff for us today. Okay.
At least you don't have the
Sharing.
XML.
Got share screen. And computer sound. Okay. So do you see my stuff?
I see your stuff.
Yes.
That sounded wrong. I see your screen.
Wait. Oh. I can't hear. Oh my God. Now I can't hear you guys. Oh, come on. What happened with Skype? Oh. Why did it mute you guys? I can't hear you.
We are not saying anything.
Wait, I'm gonna stop sharing. Okay, can you speak again?
Hey, Fotis, can you hear us
Oh
now?
no, speakers are muted. Why? Come on.
Oh, we have all been there. The hours I have spent routing audio.
Oh, it automatically turned down the volume. Okay, it should work now. Can you speak again?
Hello,
Please.
Fotis.
No, still can't hear anything. What is... Oh, I hate this. I'm gonna log out of Skype and connect again, I guess.
Okay, so while you're figuring that out, I will go. And naturally, what we're going to do is to continue working on some C++ live. So let's get our hands dirty. And
Did I start up ChatGPT?
Yes, do you want to do that? We can do that. We are going to work on problem 7 of Project Euler. Let's see what that one is about.
By the way, to be honest, ChatGPT sometimes helped me a lot.
Oh, in your project?
Yes.
Can you give us an example?
File factory.
Yeah. For real?
Yes. I was in my previous version in the previous year. Yeah, I was trying to make file factory in my way, but it's grown very big and very messy, and I'm asked ChatGPT to help me with that, and he suggested a lot of more compact version of it. So I like it much than mine.
Are you using
Nice.
3.5?
Yes, yes.
Cool. Leandro, what number, Euler problem number was it again?
We are gonna do number 7 today,
7.
or at least we are going to attempt to do number 7. And now is the real stress test for this machine. So if you're watching this on YouTube, let me know if the stream is still smooth and fine, because to be honest, YouTube seems to be complaining about not receiving enough data, and OBS is also complaining about, oh, come on, OBS. Thank you. Encoding overloaded. It seems like my computer is struggling to handle all this, but I really wanted the computer to be able to handle all this.
Leandro, can I ask one question?
Yes.
I'm not following your YouTube videos a lot, to be honest. Sorry for that. But what about your auto mixer?
Oh,
Did
yeah.
you finish it, or it is still under development?
I am still going to work on it, but I haven't worked on it in a while, to be honest. I still have lots of plans, and I will get back to it, but yeah, I haven't developed anything new. And
Good that you have plans.
Yeah. Yeah, and Matthew is saying, it's a shame 3.5 was cut off so long ago. 3.5? It was slowing down a little when Fotis was speaking. I see some minor video issues now and then, but audio is fine, so it's okay. Probably Apple doing some stuff. Activity Manager, also Microsoft, I think, were not native in the past. Okay, yeah, so it seems like the stream is reasonable, but I guess I already have my answer, because here's what changed. And this is why I'm asking you about the stream quality. I now have the proper setup that I want, with the laptop connected to a second display and connected to some other peripherals. And I don't even have the good camera. As you can see, I look all grainy. And I don't sound awesome either. I'm using the built-in microphone in the MacBook. But I really wanted the MacBook to be able to handle everything. But apparently it isn't, because I just loaded Visual Studio Code and I loaded a file and it was already struggling. So I guess I will need to come back to the 2-computer setup. It is what it is. I'll deal. All right, so problem number 7. What is it? And you at home can attempt to answer this with ChatGPT or with your own code. Okay, so again, it has to do with prime numbers. By listing the first 6 prime numbers, you can see that the 6th prime is 13. And then we are just looking for this prime number. Is it that simple? The 6th prime is 13, so it starts counting from 1. 1, 2, 3, 4, 5, 6. Okay, this program is very simple in concept, but it's going to be very slow if I brute force it. I think that that's the point of this. I think that that's the intent. At the same time, we are talking about C++, which is very fast. So
I'm back.
Oh, hey, Fotis.
Sorry.
We are in the middle of some Project Euler stuff right now, and I remember that I need to share my screen here.
Yeah, Skype apparently decided to stop working using my sound card, my external, so I had to switch to my onboard. And also it needed an update.
Oh.
But anyway.
Okay, so I'm gonna try and brute force this, and maybe I can get by. We'll see, we'll see. I don't think it will work, but let's do it. So I will need to first count how many primes I have seen already. And last time we had a whole discussion about numeric types. I'm just gonna go with integer, because definitely this number fits in an integer, so I'll go with that. And this is the I want to say the position in the sequence of primes. Yeah, I'm going to call it the position. Position in sequence of primes. And as usual, I'm going to solve this problem first, and then I'm going to change into this problem. First, I'm going to assert the correctness of my implementation, and then we are going to try and solve the problem. So while the position in the sequence of primes is less than the number 6, so we are looking for the 6th position in the sequence, we are going to keep running this loop. And then we need to have a candidate for the prime number, and that one I am not so sure will fit into an integer, because this number is quite big. So C++ numeric types, and this table, yes, we are with an integer and I want to go up, so I am going to batch that in a long that will fit. So we'll have a long, a prime candidate, and we'll start with the number 2 because we know that 1 is not a prime number. And I'm going to check if it is prime. So I'll have a boolean and to begin with, the number is prime until I prove it otherwise. And then I will have a for loop, and since the prime candidate is a long, this will have to be a long as well. So a potential divisor of the prime candidate is going to start at 2, and I want to go up to but not reach the prime candidate, and I'm going upward, so that. And if it is the case that I take my prime candidate, I take the remainder of the division between it and the potential divisor, and if the remainder is 0, then the potential divider actually is a divisor, and the prime candidate is not a prime number. So I will just bail out of this loop. I'll bail out of this loop. I don't need to keep checking. And I will say that is prime is false. So after this loop, if is prime is still true, it means that the number is prime, and I can increment this number. And then I will need to check what is the, I will need to print what is the prime candidate. And I don't remember exactly how to print stuff. I will go back here and refer to this line. And what else? I want to print the prime candidate. And there is one thing missing. I need to increment the prime candidate at the end. So I guess I could turn this into a for loop. I'll turn this into a for loop. I'll skip the first leg of the for loop because I would set up this variable, but I need it elsewhere. No, I actually don't. So I can actually put this here. And then at the end of the loop, I'll do this. I wonder if this makes my code more readable or less. It's definitely terser. But it is awkward that the initialization in the for loop is about one variable. The end condition is about one variable, but then this is about another variable. Oh, anyway.
I'm coughing here as well, but I have the luxury of muting my microphone.
Yeah, I will get my whole setup back, and then I will have a button to mute myself as I'm coughing.
That's okay.
Okay. Anything else? No, I don't think so. Let's try and make this. Oops. There. Okay, 14 is not a prime number. So this code is not correct. But it is close enough to a prime number. So I suppose it's just one off, because this ran at the end, maybe? So how about at the end of the loop, we do this. Now this is the right answer. Let's check if I wanted the 5th position, if it would have been 11. Jeez. I thought I was doing better. Okay, it is 11. So the program seems to be correct. Now all we gotta do is put this number and wait. And I'll leave it running. And we'll see if we get an answer by the end of the stream. And remember that I'm also streaming and I'm on Skype and whatnot. So if we get an answer, it's really good. All right then. Fotis, do you have your thing set up?
Yes, it's all set up. You can hear me and I can hear you, so that's a plus.
Yay.
Awesome. So let's share. My entire screen. And hopefully it's gonna work this time. Can you unmute your mic, Leandro, so I can check out?
Hello, hello.
Okay, it's working now. Anyway, so HISC crashed just now, and it's not closing. Why? Oh, there is a nice tool. It's freeware, and it's called Kill Process, and it's better than Task Manager. So, where is it? Oh God. Oh, there it is.
In Linux, you have it natively.
What's it called? Can you type it in the?
Just kill.
Oh, just kill. Okay.
Without just.
Okay.
Kill.
I gotta kill HISC. Come on, let me do it. Anyway, so I have 4 things for you. So remember when we did the filter the last time, the filter light? I just wanted to report that I did a very minor upgrade. Okay, this is getting ridiculous. Everything is going wrong in this stream. Where is Psyche? Okay. So this is Psyche's repository. Oh, there we go. Finally. Die. I said die. Die. Okay. Oh. Oh, it even got the sound effect. Did you guys hear it?
I heard that.
Yeah.
What is the advantage of this app over the Windows Task Manager?
I think it's more aggressive.
Oh.
It
Anyway,
makes a sound.
and yeah, not just because of the sound.
But
Anyway,
I think that
on-
the Task Manager still have some tricks up its sleeve. It's privileged in Windows, and it runs even if your machine is really struggling in terms of resources.
Yeah, but it didn't in this time, and I don't know why. So where is it? Not this one. It was a bit older. Filter. There we go. So a couple of weeks ago, Psyche did a little adjustment to his JSFX filter because it was reporting incorrect plugin delay compensation for DC and FIR. And all I did was just copy and paste these values and replace this stuff. So my filter light is up to date. Almost up to date, because a few seconds after I copied and pasted this code, Psyche coincidentally did another change to filter. But it's like he was spying on my computer or something. But fortunately, those changes were only on the GFX part of the code which we got rid of in the first place, so I didn't need to copy this stuff as well. So that's out of the way. Secondly, I created a fake, not fake, a test GUI for my upcoming Juno synth clone, and it's this. It's gonna be called Ogo, because you know my birthday is in August, not June. Thanks, Dad, for the suggestion. So I copied the colors and the structure from the Juno. Do I have a? You guys probably know how Juno looks like, but do I have a picture? No, this is wild. Yeah, let's look at a random Roland Juno so you know what I'm talking about. The 106 is the most popular one. I think because it has it's mostly the same as Juno 60. They have some minor differences in the filters, I guess. No, this picture looks better. Oh wait, this is the VST version. This is not the actual hardware. Roland did create. If you're interested, you can register to Roland Cloud. But the thing is that the reason why I'm doing this is because everybody has been trying to make their own Juno clone. Like 8DO has made it with SoundPaint. Air Music Technologies, Arturia, Cherry Audio, and I have the Cherry Audio variant. Also, I have 3 different recreations of Juno in Reactor, and I think it's also been made in the freeware VST, I guess. But yeah, I have an abundance of Junos, and there are still some Junos that I don't have. But this time I'm gonna create something different. So let me explain. This is how a typical Juno looks like. You have your LFO, DCO this is the main oscillator, and you can change between square and saw. You can choose the pulse width modulation. You know this stuff. You have the sub oscillator, the noise oscillator. If you want to make drums, you have octaves, and this is similar to the drawbar piano, which is why it's called in inches. We have a high-pass filter, a voltage-controlled filter, a voltage-controlled amplifier, your usual ADSR, a chorus effect. I actually have the Arturia clone of the Juno chorus, and it has 2 settings. We have a transpose, and then you have the programmable banks and stuff. And let me show you how a usual plugin interpretation works. 1 second, it's loading. So I want to describe how my Juno ripoff is going to be different. So this is by Cherry Audio. We can use the keyboard here. Anyway, so you have basically the same stuff, but in a different organization. And this is the cool thing, that even Roland's plugin interpretation of Juno is slightly different in regards to where this stuff is, or the colors are slightly different, or if they add or remove stuff from the original, because these things are basically useless in a VST, right? You don't need, so they replace them with arpeggio like we saw earlier. Now my Juno thingy is gonna be a bit different. So we have the LFO. First of all, it's not called the programmable. What was the? Sorry. How do they call it? Oh, low quality. Oh yeah, programmable polyphonic synthesizer. Algo is a wave-morphable crispy phonic rumplicizer. I will explain. Crispy phonic is from crispy samples. You know, I even ripped off the Roland logo to make it look like crispy. That's on purpose. I'm not gonna get sued. So we have the LFO. SBO is called sample-based oscillator, because I'm gonna use the samples that I got from Sample Science, the analog waveforms. I think I've talked about them in a previous stream. Basically, Sample Science has recorded saw, pulse, square, sine, and the triangle from synth. I think it was called Morpheus. And these are very good waveforms. He sampled them key by key, and you can get them for free if you type sample analog waveforms v2. And they are in the public domain, which means that you can download them from archive.org and do anything you want with them. But I did donate a couple of bucks to his Gumroad because I loved what he did. You can also download it as a VST instrument that he created with Maze, or you can get the samples themselves in WAV format. So I'm gonna use these instead of using the oscillator of HISE, because I want it to have a little bit of grit, a little bit of noise. And here you will be able to select between 4 waveforms, not just 2. The ones I described earlier, and how much they're going to be affected by the LFO. And the noise, I guess I'm actually going to create this one with HISE. The noise, I mean. These all things will be recreated in HISE using Vector. So I have some tutorials from David Healy's Patreon on how to draw these things with Vector, so the interface is resizable. And even the gradient in the background should be able to recreate in Vector.
And do you draw this, or do you code this?
Yeah, you code this. You type the stuff like you would in SVG, like coordinates.
Would you be able to alter the SVG in Inkscape and use it, like you can for VCV-Rack?
I have used Inkscape a lot, and I didn't use it for VCV-Rack, but I did load a couple of SVGs in GitHub, and you can actually see the source code of the SVGs, which is hella cool. Yeah. AMF is analog modeled filter, not voltage controlled filter. And we have the low pass filter, the high pass filter, and the what the filter. Yeah, this means what the filter, not the other.
You have me going there for a moment.
Yes, I'm gonna. Yeah, we'll see where this goes. We have the DSR envelope. H stands for hold, and HIC already has this, so it's nice to have it. If you want to test it for yourself, you can try it in Vital, the synth which is free. Vibin is going to be a variation on the Juno vibrato I want to make to create different types of vibratos. Like I'm gonna use a different LFO like this one. Like this one is going to change the amplitude like a tremolo, but this one is going to change the pitch like a vibrato. And we're going to select the shape. Maybe I should type shape here as well. I forgot. And morph is going to create a wave morphing. So I should be able, I'm gonna add some little icons here and also here, so you know which waveform you're using. I just haven't decided on the waveforming, and I will get back to this later. Dirt is going to be distortion, and this one, XY, what the filter, is going to be, remember how I made an XY pad in HIC? I'm gonna use the same code in 4-axis, WTF and question mark, and each one is going to shape the filter that you're going to tweak with this knob. And I'm considering using what I've learned from filter, like I can create some custom filters based on the EQ curves that Psyche used. I could implement some similar stuff. It should be cool. And also, obviously, it's going to have MPE mode and the pitchy bendy, the pitch bend, and some volume and load and saving presets. So do you have any questions about that before I move on?
That's very ambitious, yeah.
Thanks.
Looking forward to it.
Okay. Secondly, I'm going to talk about this at the end. I'm going to talk about what I'm working on right now. And let's see if it works. And if it works, I'm going to scream happily. So for the first time, I used this tool, and I had to. It's called SFZ to HISC translator. Now, as you may remember, HISC does contain its own SFZ importer, but the problem is that it's very rudimentary. Oh, by the way, speaking of HISC, it's getting a lot of commits lately because Christoph is implementing his own kind of time stretching inside it. It's not complete yet. It should be in a few days, but he's been working like crazy lately. And there is a separate commit called feature time stretch. And when it's done, I guess it's going to be implemented in the develop commit. So you have to go to view all branches and go to this one, feature time stretch, in order to see what he's done. And I've built it. It's gonna have fuzzy search, which is cool. It's almost complete from what I can say. I'm going to test it later, but the interesting thing I found in the latest repository is that in the tools, there is a new SDK called Perfetto. And when I was ready to build the standalone project with Producer, it gave me 3 different options. Usually it had to like release version with Faust, release version without Faust, and the debug stuff. But now we have a new one that's called release with Perfetto, and I didn't build with this way because I didn't know what it was. But apparently, Perfetto is an API created by Google, and it's about performance instrumentation tracing for Android, Linux, and Chrome. I'm suspecting that because Christoph is working on a web view version of HIC, maybe this thing is going to report bugs, like it's going to be for bug tracking, I don't know. But what if he's also working on, I don't know, this is just speculation, but what if he's working on a way to create HIC plugins for Android? If that would be the case, that would be amazing. Again, I'm just speculating. I'm not going to ask him. I want to be surprised. But yeah, the fact that this is in here is interesting. And if you want, I can show you in the SDK stuff, we have this CC and the H file, and it's created by Android open source project. And you can check out for yourself on the GitHub. Again, you have to go to the nightly that I mentioned earlier, that one that's called feature time stretch, so you can see what all the fuss is about. Oh, this is interesting. Do you know this quote? Ceci n'est pas une pipe. Have you guys heard about it?
It is Magritte.
Yes, it's a Marguerite. Marguerite. Now let's load up HIC, and once I'm done with what I'm working, I would like you guys, the help from you guys, so I can create something unique in JSFX. Because I have another idea, and it's gonna be sweet. Standalone builds. So the intention here, sorry, have you, I'm guessing you guys have heard of the SFZ instruments group on Discord, and one of those, the Salamander drum kit.
Actually, I don't know what you're talking about. Can you explain?
Yes, I will explain. So some people on Discord have created this, not this repository, I'm talking about this profile right here, and it's called SFZ Instruments. And here you can download many sample-based instruments for free, and with all the license information and in WAV or FLAC usually, and with the SFZ mappings. Now the thing is, most of those samples are using the second version of the SFZ protocol, SFZ 2.0, and actually a modified version of that, which is called SFZ 2.0 with ARIA extensions. ARIA with an I, not Y, like our friend. So let's load. I'm gonna load for Zando, which is the only freeware application that can load SFZ with ARIA extensions, because Plug, the creator of Zando, was the co-creator of ARIA along with Gary Tan, a company that's creating sample-based instruments for Finale. I think it's for Finale. You may have heard about it. It's called the GPO, the GPO Orchestra. Anyway, so if we load this thing, the Salamander drum kit, which is available in GitHub. Sorry for going back and forth, but I have to demonstrate. I have to explain everything, all the things, so you get what I'm talking about. So the Salamander drum kit is one of the most popular free and open source drum kits, and this is the original GitHub commit. Alexander Holm has also created the Salamander piano, which is also very popular among the free and open source sample libraries. Now, the problem with this drum kit is that some of the samples had some errors in them, like they had some unnecessary silence before the samples. And this person called Essage edited all the samples that had problems and also created a new Salamander version. Where is it? Yes. So you have to go to this branch, the README update, so you can get this file called Salamander drum kit trim.
How do you find this
and if
stuff?
you want to get the edit, sorry, I can't hear you, Leandro.
How do you find this stuff?
You got muted again? Oh my god, I think it's for Zando. I think it's for Zando is the reason why it mutes you.
Oh no.
Come on. How do you do that?
Fotis.
Oh god, I hate Skype so much.
Like tons of information.
Oh, maybe it was working. Can you talk again?
Hello,
Hey,
Fotis.
Fotis.
No.
Hello, Fotis.
Oh god, I hate it. One sec, I'm gonna check the... I'm gonna sweep back and forth. Okay, now it works. Phew.
Hello?
Oh god.
Can you hear
Okay,
us?
so what were you talking about, Leandro?
Okay, I was about to type that for you. No, I was just commenting on how do you even find this stuff? It's a work in progress branch in a repository with just a couple stars.
Yeah, I started the original one, and hold on, let me show you. So if this is a GitHub trick that you guys should know. So this is the original
Let me guess,
repo which has 21. Oh no, you don't have to. If you start it, then it's going to notify you. You have to sort this by recently active, and it's gonna say update 2 days ago. And then you have to go to network, to insights, and then network and see the branches. So yeah, if you start a repository and then sort them by recently active, you can know if this is happening. So there you go. You learned the GitHub trick. Now.
Amazing.
Yeah. So let's go to HIC. Now this importer is loading SFZ2. It doesn't support area conversions, area extensions yet. But which have a few more opcodes for SFZ syntax, but it's very close. Oopsie, that's not the right thing. Let's go to my samples folder and go to drums. So this is the original file that I downloaded from GitHub. But the problem was that the importer couldn't load the key maps. It didn't know which key you had to assign each sample in. And I read in the manual that you have to split the opcodes, the headers in one line. So what I had to do was use a regular expression. So you replace this word, for example, with this word, \n. And so this is what I came up with. This is my edited file, my second edited file, in fact, because I had to do one more trick. So you can see I broke those into new lines. And also I had to take the key label from the master group and copy paste it into the group header, because otherwise it wouldn't read it. So then you press this button and you get all the HIC sample maps the way it wants it. And also you can, I haven't tried those yet, I'm gonna do it later. You can copy this stuff and paste them and you get JSON files. This is the extended one. So you have the opcodes. And this is the same thing, but it's in a slightly different way. So it uses a variable like that. And there's something different as well. I think it adds numbers on some part. I don't know. You can see it in the manual. So I'm going to link to this and also the manual. Now, let's go to HIC and see if my edits were right. I think it was fun to work on. Oh, so it loaded it because I copy pasted it in the folder. I copied the samples in the sample folder and the maps. I also copied the JSON. I don't know if you're supposed to copy them in this folder, but I didn't. If you don't, maybe some other, maybe this here. I don't know. Let's see if it works.
Drum roll.
Drum roll.
So
literally, because I'm using a drum kit.
Such short time window.
Oh. Oh, I guess it's loading all of them. Or did it crash? Again, this is a very nightly. So it could be volatile. It could crash at any moment. But
it seems to be making progress.
Yeah, it. I promise I won't scream too loudly.
Use mute button.
It was
Okay.
making progress, then you put your cursor on it and it got shy.
Yeah. So, and this one is, yeah, it's working. So while it does, it's going to be a bit slow. While it is working, let's go to the JSFX realm, because I had a nice little idea. And we should be able to implement it. If we are lucky, it's going to need a few copy-pastes. But I want to know specifically which copy-pastes I have to make, because you guys are the JSFX lords. I didn't say kings because king is Psyche and prince is Toucan. So, like I've said in a previous session, this person called CH Maha has created their own copies of Air Windows to JSFX with slightly different names, but you can know which one it is by looking at the source code. There was another person there, maybe you've seen that bow, a person from Ukraine in the Air Windows Audiophiles Facebook group that renamed those JSFX by hand, but only the descriptions, not the names. So they appear correctly, but they were behind, so I had to synchronize those and repack. Anyway, I digress. So this is tape delay 2 by Air Windows, and this is the JSFX port called Acoustics Tape Delay Echo. I don't know why he named it this way, but anyway. So I'm gonna load ReaSynth. Oh, yeah, I have to select the output.
Well, we heard that.
Oh, you did? Okay.
Mm-hmm.
So if we turn on... You have to check a few of the parameters. Now it works, okay. Because if you have it full wet, you're only going to hear the delay. So you have to go have it on 50%. Anyway, one of the things that Air Windows cannot implement or hasn't found a way to implement in his VSTs, is the ability to synchronize a delay to the tempo of your song, or more accurately, to split it in quarter notes or eighth notes, to synchronize it in notes. Mm-hmm. And from what I've seen, it is possible to implement it in JSFX. I have found a couple of delays that do that. If you go to JS and type delay, I think I found one that does it already. What was it? There is this tempo delay.
I know how to do it, by the way.
Oh, really?
Yeah.
So let's load these things so I can make sure which one I want. Oh, I think this is what we want.
Well,
but,
not quite, because this is not syncing to the project tempo. It's syncing to its own thing.
Yeah, it's its own thing. Oh, this is, if you go to 0, it goes tempo sync. So there's that.
And then fraction of the whole note.
Fraction of the whole note. And also it has ping pong here. It's the same thing. Oh, and this one is interesting. So should we steal the code from this one?
We may, or we may recreate it from first principles. It should be doable.
Okay. I found that there is a variable called tempo in the other thing. So let's create, I forgot how do you create the, okay. I'm gonna create a duplicate. There we go. Now we can make all the adjustments we want.
Cool. So there are some magic variables in JSFX that give us the project tempo. Can you first show us what is the project tempo? I mean, We want the tempo and the BPM, right?
Yeah, 110, 20.
120, and we are in 4x4.
Yes.
So we want to look up the variables that give us that information within JSFX, and they are just magic variables, or I guess they are called system variables in the debugger on the right. So you can either scroll the right pane and look for those variables, or we can look up the documentation.
Okay.
It's going to be under system variables.
Oh, temp samples? No. Oh, system variables. GFX, bit position, MIDI bus, mouse, PDC, play state, sample block, slider tempo.
Yeah.
There it is.
There is the tempo variable, and then there is the TS for time signature.
Time signature.
Numerator.
If I change it, does it change in real time? No, yes, it does.
Cool. And it's necessary that it changes in real time, because you may have you may have tempo modulation along the master track. So what we want is to use these three variables to determine how long the delay should be in milliseconds. Or is that how you determine the length of the delay in this plugin? As it stands.
Yeah. It's milliseconds from, if I remember correctly. Or maybe just percent. It says time.
It says time. Awkward,
I
right?
checked another plugin, and I don't know which one, maybe tempo, like you searched earlier, and I just nicked the code.
Oh, also we have remember this thing, the parameter sample and hold? Here you can choose the time in milliseconds, and also you can split by quarter notes. So this is interesting. And this is a read-only. It's a very nice feature. I love it. But I don't know, maybe the code will be useful. But anyway, let's do it ourselves.
Yeah, that code actually does something that we could use, and it wasn't that long. But anyway, let's try and make sense of this from first principles. It could be fun. So how do we even begin with this? If there are 120 beats per minute, and each bar has 4 beats, then is Bo sending the answer?
Did you use
that's the one
ChatGPT?
I took, and I sort of and I think the slider is dividing, so you get divisions for
60/tempo. I've actually seen that before.
Yeah, that makes sense. You are taking how many seconds there are in a minute and dividing by the number of beats per minute.
So that's what I stole. Appropriating.
Okay. 90% of coding is stealing.
Yeah, so
99.
which route do you want to go? Do you want to try and copy and paste stuff? Because the last plugin you showed us seems to have reasonable code.
Oh, sorry. Who is this Matthew Bishop person? He has joined our call, and he even reacted to the block of code that Bo just posted.
He showed up in the chat earlier.
Yes.
And we encourage him to join the chat. So
Yeah.
Yes, please.
You may
Say
even
hello,
join the
what
call.
viewers.
Just so you know,
Yeah, he
you are
joined the
welcome
call.
to join the call. No, he's
I
in the
remember
chat.
a few study group meetings ago that the creator of Faust, S. Leds, had joined us, but he remained silent for the entirety, and he left. So that was creepy.
Not at all.
No, it wasn't.
Okay,
anyway,
so which
so I
route do you
guess
want to
it's
go?
tough.
Do you want to try and work on this based on someone else's code, or from first principles?
I'm gonna copy this in a notepad.
No, this is code for the other thing. This is C++
Okay,
for
sorry. So the Euler.
Project Euler stuff. Yeah,
Okay.
we'll look at that later.
Okay, so I'm getting this stuff. Oh, Matthew is typing.
I should ask ChatGPT to look up tempo font.
Yeah. But you can probably explain that. Oh, Matthew doesn't have anything to show. Okay, that's cool. Anyway, thank you for joining us, Matthew.
Yeah. And you may not have anything to show, but you may want to join the call and tell us what you are interested in learning. It is a study group after all. And then we can provide external accountability. Next meeting, you can join us and we will ask you about the stuff you said you were
Maybe,
interested in.
do you know Matthew? Do you know Matthew from Discord? Maybe, because there was a person that wanted to join us.
Yes. All right.
And
so, Fotis,
yes.
what do you want to do? Do you want to try and make sense of someone else's code,
Yes.
or do you want to try
No.
and work on this from first principles and
The
figure out the
latter.
math? All right. So let's try and figure out the math ourselves.
Uh-huh.
Our goal is to have the length of the loop in milliseconds. I know that in this plugin, it's measuring from, I guess, 0 to 1.
Mm-hmm.
I have no idea what that's about. So let's try and figure out it in milliseconds. And if we can, we'll count ourselves accomplished. And then whatever is happening on this plugin, we can figure out later.
Mm-hmm.
So the question is, given the tempo, the numerator and denominator of the time signature, what is the length of that given amount of notes? So let's say that we want to know 1/4 note. How long does it take? Where would you start, Fotis? Where would you start answering this question?
Do I create a MIDI note and measure it like 500 some?
That's an interesting approach to it. It's very experimental. I like it.
I don't need the MIDI note actually. I can just use the thing,
Yeah, because in
and
Reaper,
we
the
can
measure-
actually use it
Yep.
in.
If I
where is
may
it? Yes.
interject a bit, I think I don't think the results is in milliseconds, but it's actually a number of samples.
Oh,
stored
yeah, that's
number of
probably
samples.
what Chris is doing.
Fair enough. Yeah, to convert from milliseconds to the number of samples, we know how to solve that problem. We have the S rate variable in JSFX that gives us the relationship between samples and time. So that part is relatively more straightforward. But I think that trying to guess the tempo in milliseconds is more useful.
Mm-hmm.
I think that is a stepping stone toward the solution.
Yeah, that should be easy because 120 is basically 2 beats per minute every minute. Or because if it was 60 BPM, you would have 1 beat every minute, right?
No?
Sorry, every second.
That makes more sense.
Yeah.
No,
So
hang on. What did you say? Can you repeat that?
yeah, if you had 60 BPM,
Okay.
that would mean 60 beats per sec, 1 beat per second.
1 beat per second. And
So if you go to 120, 2 beats per second,
2 beats
No.
per second, and each
or 1 beat per 2 seconds. No.
No,
2 beats per
no.
second.
It is 2 beats per second, as you can see in the roller. You came up with an interesting approach where you're using the Reaper measurement, and yes, you have selected 1 beat, and it takes 500 milliseconds or half a second. And I don't think that this is in samples. This ruler is telling us seconds and milliseconds.
Yes.
So, what is the relationship here? We are growing BPM. The BPM went from 60 to 120, and the length is shortening, right? So these two things are inversely proportional and linearly so, which is good. So that's where the 60 divided by tempo comes in. Tempo is the denominator. The bigger the tempo, the shorter the duration. Cool, huh? And if we just take 60 divided by 60, we get 1 second. If we get 60 divided by 120, we get half a second. So that seems to be okay, and it is giving us an answer in terms of seconds. And that's equivalent to giving us an answer in terms of milliseconds. I'm fine with that, because seconds and milliseconds is just dividing or multiplying by 1,000. And it may even be more convenient to have the answer in seconds, actually, coming to think of it, because S rate is given in samples per second. Or yes,
so do I look for the S rate variable? No, or we have to input it ourselves?
No, the S rate variable is probably, yeah, it's already there. Overall scale, see overall scale times S rate.
Oh, this one? No.
Yeah, there.
Oh, that one. Yes, I just said. Awesome.
So the next part is you probably want to have a slider. I'm coming to this from like different pieces. I'm thinking about this bottom up. So I know that we need this relationship between tempo and, I guess, seconds of delay. So that's one piece, and we can set it aside. Now the next piece is you probably want some slider, right? You want the slider to, or maybe you want to change the existing slider. How would you want to do this? Change the existing slider or create a new one?
Probably we have to change the existing one, because this slider is getting referenced again. Now we have to. How do they do it? Like, for example, let's look at a famous free delay. So this is how it works. If you sync it to tempo, we have the metronome here. You have the denominations. But if you turn it off, you have the milliseconds. Ideally, we could create a drop-down menu so you can choose between milliseconds and tempo, which means that we have to both create a new slider and adjust the one that we have so it uses milliseconds instead of samples. And the second one would be, like, we need a drop-down menu that you can choose between tempo syncing yes or no. And then, so yeah, let's recap. First of all, we have to change the existing slider from samples to milliseconds. Secondly, we have to create a drop-down menu to choose yes/no tempo sync. And thirdly, we have to create a new slider. We have to change, to make it change again. So it goes from milliseconds to fractions. Isn't that how you call this?
I would call them time signatures.
Time signatures, okay. Because I don't know if these qualify as time signatures.
Oh, fair enough.
Bit divisions. Yeah. So let's call them bit divisions. I don't know if the time signature variable is going to be useful, but it would be interesting to create an odd time delay, maybe for next week.
Yeah, okay, so go back to your list, and I can see one issue there. The existing slider is not defined in terms of samples. It is just an arbitrary value between 0 and 1. So, yeah, you will have to figure out what is happening there. And then
Mm-hmm.
the drop down seems reasonable. And when you say that you want to change the slider to go from milliseconds to beat divisions, in JSFX there is no way for you to change a slider. There is no way for you to change the range of the slider or the steps on the slider or anything like that.
So we have to create a new one.
What you can do is create multiple sliders
Oh.
and show and hide them. And
okay.
they can have the same label. So it will seem as though you're changing the slider, but you actually have two of them and you're just showing and hiding.
So when you choose yes, it's gonna hide the existing one. It is gonna show up the beat divisions one. That would be amazing.
Yeah, and since you were so diligent taking notes of everything, and we have already talked about what we want to do, I am going to do it like this. How about, as homework for next time, you come up with the arrangement of the sliders. You don't have to write the code that is actually going to compute the things that we care about. You don't have to write the code that is going to translate from milliseconds to samples or from beat divisions to milliseconds. None of that. We can write that together. But I wanted to try and write the multiple sliders and the drop down and the show and hide. And you can check out the documentation to learn how to define sliders that don't show up. And you can read the documentation about the slider show function, I think it's called, that it will let you show and hide sliders programmatically. So the slider may be hidden based on some condition. And this is something that we have covered in many streams in the past, so you may want to dig in the catalog and watch them. But yeah, this thing that you are proposing should be doable, and it will seem as though the slider is changing the unit of measurement. And you may be wondering why plugins, you showed us many plugins and they don't do that. You may be wondering why. It is because it's a relatively new feature. I think it's only 1.5 years old or something.
Yeah, and Chris is using C, not even C++, and he's still figuring out many things. Okay, so yeah, that's awesome. I'm gonna do this homework. And one final thing I want to show before wrapping up. It worked! Or it didn't. Wait, why doesn't it show me the samples? Oh, maybe it's right here. Oh, come on.
You can tell that the interface is a bit glitchy. The word sample table is going over
it's a glitch here. Maybe I have to wait until the next, or I have to roll back into a more stable build. Emphasis on more stable, not the actual stable one, because I'm a bit testing thing like that. Oh, maybe I have to press this. Anyway, I'm gonna check this out on next time. And one final thing I want to show, because we were using the Salamander drum kit. This is going to be an image on the GUI. I created this on Mid-Journey earlier. It's an actual Salamander playing the drums. It should make for an awesome GUI, right?
Yeah, it looks great.
And I'm gonna use what I've learned from this test to create the second version of my organic calfskin kit.
Oh, nice. That was the plan when we started the study group.
Yep.
We're finally circling back to it.
Yeah, after a year, we've all learned so much, and I feel I'm even more confident. And the reason why I'm using these test builds of it crashed again. Beautiful. So I guess I'll have to wait for the next commit. But the reason why I want to choose this time stretch is because it's been a feature in Contact for a couple of years, and Christoph is implementing his own solution to it, because it's going to be useful in both orchestral libraries and percussion libraries, where, like, for example, sustained cymbals or stuff like that. And, if you want to check it out for yourself, there are two variants of the Versilian Studios chamber orchestra. The one that is freeware is in SFZ format, but the commercial version is in Contact because Sam, the creator of Versilian, told me that he's using Contact for the commercial version because it has its own time stretching implementation, which he used in a couple of violin samples. Like, so when you input a note, you can time stretch the sample in real time, and that should be hella cool. Imagine if you will be able to do it in HISC. So we have an open source version of that. Hooray. And I wanted to ask something because I said that as for Zando, although it's freeware, it's not open source because it's using this proprietary extension called ARIA. And I remembered one of your earlier Reaper streams before we met. Actually, I was just a lurker in the chat when you were discussing about the copyrights of Reaper and the licenses it's using. And you said that because Reaper is closed source, it can get away with some stuff that it wouldn't if it was open source. Do you remember what was that?
No. But I remember that there are some things that Reaper uses that are licensed in different ways if you are doing open source, like the Elastic time stretching algorithm.
Oh yeah, the Elastic, yes. Definitely.
Yeah. I don't think you could, well, I am certain, 100% certain, that you could not redistribute Elastic as the source code. Now, I think in theory you may be able to have some open source project that links against Elastic, but I don't know. Licenses are complicated. I'm not your lawyer. Don't quote me. I'm out.
Yeah. But it does use a couple of open source time stretching as well, such as Rubber Band library. You can get that from GitHub. But the Elastic is proprietary. It's created by Zplane, and they only use it to be licensed by DAWs or other people's plugins, or their own plugins for that matter. Because Elastic can also be bought as a VST, and it can be found on Reaper and Bitwig, if I remember correctly. I think they used it on Cubase as well, maybe. No, I don't know. And also I found Elastic on a plugin by Audio Modern called the Loop Mix, which I bought, and it's very good. It's very nice too. Oh yeah, and also Ubershall Elastic. Oh no, it's called Elastic with a K, but it's using the Elastic with a Q. It's complicated. Anyway, plugins are silly. Skype is stupid. Sforzando is stupid. I hate everything. Anyway, that's
Do you want a hug?
Yes, please. Oh, I love you guys.
Good one.
Bo, did you set up everything for us to see or to?
Yeah, except for the audio. I haven't really learned how to route the audio to Skype. So if we could do that.
Are you on Windows or Mac OS?
Windows.
So that should be relatively straightforward. When you're sharing your screen, there should be an option to share the audio. In Mac OS, I don't think that option exists.
Are you using Sunflower or Blackhole or some of those Mac drivers? Oh, no, you're using Windows, right?
Yeah, I'm using Windows, exactly. So let's share screen. Start sharing. Share computer sound.
How cool.
That be enough?
If only macOS could do that. Well, now we can actually, since I think Ventura, there is an API to share audio between applications. But it seems like Microsoft didn't pick up on that yet. Anyhow, this is one of the first plugins that you developed, right?
Not really. I did a couple of just sort of learn my way around it. What the delay thing that I copied the code from was one.
Oh, okay. Well, it was definitely one of the first that I saw from you.
Possibly, yeah, possibly. So let's see, where's preferences in Windows?
It's under Edge, isn't it? No, it's not. What do I know? Maybe under Options? Preferences. There it is, the last one.
Control P. So we should have audio device. Speakers head from primary. Fotis, this should be your space.
Yep.
Should I use the primary sound driver or?
It's the same thing, both of those. Since you only have one sound card. Did you check share computer sound in Skype when you pressed the share screen button?
I did.
Okay.
So there should be sound. Do I need to route something in Windows options?
Oh, let's
maybe.
Let's go there. Yeah. Oh, this all looks okay.
Input, microphone, we'll take output.
Maybe the volume is too low. No, it's okay. 1, 2. Oh, we can hear the computer sound.
I heard it.
Oh, dude, did I simply just mute this one, the master volume, because I was doing some experiment?
The master volume seems infinitely low.
Oh.
There you go.
We have sound.
This whole time I thought that you were listening to the drums and we weren't.
Oh my god, this stream is full of workarounds.
So, let's first of all...
Oh, by the way, did you guys see the new Psyche drum machine? Are you using that yet?
Yeah, that's what I'm
Bo, can you please show what happens when you click the drum key on the GUI?
Certainly. It's gonna...
Can you have to stop it, the music. This is so hilarious, man. When I said it's a stupid idea, but it works so well. The screen is shaking when you press the kick button.
And the snare.
And the snare, it's slightly less than the snare, but the kick is amazing. And the interesting thing that this happens only if you click
the volume.
No, it doesn't depend on the volume, but it depends if you use it with your mouse. If you input MIDI notes, it doesn't happen.
All right.
But yeah. So thank you, Psyche, for creating a free drum synth for Reaper. That's super awesome. And also, I don't know if you guys saw, but the JSFX backend for Faust is pretty much complete. And they're working on creating the polyphonic version of it. So in a couple of months, we should be able to have polyphonic synths in JSFX.
Nice. It will not be the first, but nice.
Yeah.
The first thing I'm gonna do is digress. So I got ChatGPT 4.0. I have a subscription for that. And I did an experiment that took like 2 minutes where I fed it the JSFX documentation from the Reaper webpage and asked it to draw some simple squares. And you can see the squares, right?
Yes.
So this is what it came up with. Just to sort of feed it information and then try to make some usable code for it. So that's my first digression. But the Revolver, so there's the, I should show you this first. Where are we? This is based on, the Revolver compressor is an RMS compressor that's using, it's not using an attack and release, but it is using a curve, a volume curve, which the RMS signal is following. and the curve is adjustable to go to work this way. So this is like 0 dB, i.e. 1 times 1. And as the RMS is pushed by, let's say, a drum hit, it's going to sort of lower in volume this way. Or as I'm pushing the formula, it's going to lower the volume as such. Do you follow? Is that easy to follow? I think I explained it to you, Leandro, as we were on Basta Burger.
Yes. Very nice burger place, by the way. And I'm not sure I follow what are the X and Y axis.
So this is 0 gauge. So the RMS usually, if you have a, let's say, so this would be samples going in and out. It would just sort of.
Okay, a transfer curve for a compressor with you so far.
Yeah. Transfer curve for a compressor. So as the RMS signal will that controls the volume of the compressor. So as it is working at this range, it's doing nothing, i.e. 0 dB, i.e. times 1.
But that's the multiplication factor.
Yeah, multiplication. Yeah, thank you. So as it's pushing, it's gonna reverse the volume, so it's gonna compress it. So when I said it doesn't really have an attack and a release, it's just going to sort of push into this and then follow this curve, and the curve is adjustable.
So when you say that there is not a notion of attack and release, it is because the smoothing is done by the computation of RMS, and
exactly.
Essentially the attack and release are set to 0.
More or less, yes.
Gotcha.
Yeah. So this is the principle behind it. And this, I sort of stumbled upon this idea when I was working on my salient treatment. And I pressed the delta button and I got this really cool compressor effect. But this is what it sounds like. So the thing that I just showed you, which I call compression here. So this is
Where
like
did you get those curves, by the way?
That's a really, really good question. I think I just wanted a smooth curve for the silent treatment. I just wanted the smooth. The silent treatment does this in reverse, so a mirror image of it. So it's a once times it multiplies by one by until it reaches a threshold, and then sort of gradually and slowly silences it instead of just cutting it, abruptly cutting it.
Okay. Okay.
So it's a much smoother gate in that way.
Okay, so it's a different perspective. The axes mean different things, but essentially this is a transfer curve.
Yes.
Okay.
Yep. And the one I just showed you is this thing. So this would be the sort of where I did it this way. So it sort of it drops abruptly cuts it. So this is sort of the shape of the wave, but this works in reverse. And there's
in a way that's also setting the threshold, though I don't think you think in terms of threshold.
Not really. It sounds like a compressor, but it's not working exactly like a compressor, if you catch my drift.
Mm-hmm.
And these are the different types of RMS. So this is a regular RMS, and this is the double RMS. And I also have a square for it. So when you RMS, it's going to be more sensitive to transients. And the sort of the double RMS, and it's going to be making even more sensitive. So I can actually demonstrate it this way. If I use the delta signal. Wait, what the hell? Let's put
Guys, my apologies, but baby time is running out and I will go sleep.
Sure.
Have a good one.
Have
Thanks for
have
joining
fun.
us.
Thank you too, guys.
Yeah,
Bye.
thank you. Bye.
Bye.
Take care. So this is the delta signal. And as you can hear, it's quite smooth. There's no like kind of weird artifacts in the compression. And so this is the maxed out transfer curve.
Leandro is still dancing.
Yeah.
You know how to make funky beats, Bo.
Yeah, absolutely. So listening to the two different RMS versions, you can definitely hear it. So it's just taking the short transients, but the sort of the top bit of the transient with the double RMS, and this is the regular RMS.
When you say double RMS, you mean what exactly? You're taking the RMS off the RMS?
Yeah, that should be it.
Interesting.
So our with RMS, you square the signal and then smooth that. So it's smoothed with an IIR filter. And when I say double square, it's like it's 2 squared. So SPL in to the power of 4.
Okay. You're not taking the RMS off the RMS. You are transforming the signal before it goes into the RMS.
Yes, exactly.
Okay.
Before the smooth. And let's listen to the regular signal. But it's also
Hey, Bo and Leandro are working their beats. We're going to JSFX with some EQ curves.
This is the sort of crude, instead of a level meter, I have this slider that sort of, that would be the, what's it?
When you're increasing the gain, you are hitting that curve.
Yep.
1176 style, gotcha.
Yeah. And this is also, you can listen to the RMS thingy where it, so this is like really pushing the compressor. Kind of playing backwards in reverse. And there's also high pass. Now it's really pushing it. And I can do a side chaining. Sorry guys, that wasn't very useful. But I can side chain like a bass, and the thing with this, as I said, there's like very little artifacts going on. Usually when you use a delta signal compressor, especially like the simpler ones, there's always like crackling and distortion going on, even if it sounds okay. This doesn't crackle or anything at all. And side chaining a bass with this one also sounds really good. And like I told, when I showed this to you, Leandro, in the coffee shop, or the burger place, I use this on practically everything except the master bus, because it doesn't sound good on the master bus. But
what is the length of the window? What is the size of the window on which you are computing RMS?
Ooh, that's a really good question.
Oh, I guess you are computing RMS in the exponential moving average style. So the window is not really a question that makes a lot of sense.
So this is the EMA or IIR calculation.
No, gotcha. So I think that the window, I mean, if you were to translate this into a windowing thing, it would be quite a medium to large window size, which means that the compression is somewhat slow to respond or smooth. It is the kind of compression that is subtle, and that's why I don't hear the artifacts when you delta.
Yes, because if I increase this value, there's going to be those artifacts that you usually hear in simpler compressors.
So this is more like a gentle compression, an optical compressor, or a bus compressor kind of deal, right?
Exactly.
It's not going to be like making the room bigger or add punch. It is more like a gentler compression.
It actually does on if I'd had like a live drum room with overhead mics, it's gonna really push the room. So that's the funny thing. It's not exactly like an LA2A that's slow, a slow optical one, or a fast JFET like a DBX compressor. It kind of does both. In a way.
Oh, by the way, the samples from my organic calfskin kit do have overhead microphones, so they could be useful to you.
Yeah, cool, awesome. I did have a long story. I did have like a drum thingy set up, and something crashed and it's gone. But that's what I used to test this for. But let's see if I can find a different sound on the. Oh, sorry.
Yeah, it does have some presets.
Makeup gain.
Isn't it awesome that we have our own JSFX drum machine? Imagine what we can accomplish with this in the future.
Yeah, this is a great machine.
Yeah.
It does. There's not much room in this. I thought it could like long sound. But no.
I think I can hear. Fotis, you tell me if I can hear this correctly. But I think that Skype is doing some sort of time compression and stretching, probably because of when you lose packets, you have to compensate or interpolate somehow. Because of course the drum beat was in a steady tempo. It was like a drum machine. But I sometimes heard it like speeding up or slowing down. Did you hear the same?
Yeah, a little bit. Slightly.
Crazy stuff.
Maybe if I did like a really slow tempo.
No, you were fine. It was just here and there. It was very spotty, but it was interesting to hear that Skype is trying to do that. Like instead of dropouts, it's interpolating or compressing or whatever it's doing. I don't know.
I was actually thinking for like drawing out sound, so I could push the. There's no. If I could get some like reverberation out of it, but no. Anyways, so do you want to check out my tempo thing?
Yeah, let's take a look.
So Chris Air Windows, our dear friend, he found.
Oh yeah, I've seen that.
He found how different tempos interconnected in a kind of formulaic way, and he created an algorithm. I noticed there was pi in it, and he had a version of pi in it, and I suggested it to it. So he changed a bit, and this is the sort of the thing where you mapped the tempos, gave them different sort of flavors: testify, trample, forceful, crank, etc., etc.
This is the kind of nerdery that I live for.
Yeah, This is same here. I just love.
You can find an even more detailed one on his website, and I think he has decimals on the tempos on the website list. It's even scarier. Yeah.
Hang on, Fotis.
Yeah.
That's where we're going.
Oh.
Tempo delay. Oh, that's a tempo delay. Air Windows tempos paradigm. So I created this. I used the formula, tempo calc, feel, air window. So I think this is the actual formula with pi in it.
Oh my god.
And this is what it looks like. So I can, there's a kind of flowy thing, there's a groovy thing. He found 4 basic varieties in that circular algorithm, and as you're pushing the numbers, you get these, and I also have as many decimals as I.
Nice.
But I stick to 1 decimal. That's the nerder I get to. But also, I've been using this religiously when I create music. I stick to this religiously. So I'm not using like 120. I use 121.4. I'm not using like 100. I'm using, what is it, 100? I think it's 102, 101.9. Oh, anyways. Again, I'm using this religiously. It's on every project.
I think there was a video by Adam Neely, I think, that says, please don't use decimals in your tempos because they sound horrible.
Yeah.
What's your opinion on that?
I think he used the examples of using like 3 and 4 decimals.
Oh.
But they make sense when you get to like 30 or 20, because a lot of like weird jazz metal stuff have like super low tempos. So when you get to that point, I mean, the decimals, it scales. So 33.21 is it scales.
What is the argument against decimal points besides just being obnoxious?
Both sides are obnoxious.
I don't remember. It's been a while since I saw that video.
Okay.
I'm gonna post
it seems to
in
me there is nothing inherently wrong with the decimal points.
No. Now, what could be the issue is that some like tempo-based plugins can't handle like 3 or 4 decimals.
Oh.
So they round to the nearest integer.
Ah, good point.
But that's not a big thing. So there's like, I have one of my favorite delays, the H delay by waves. It rounds up to the nearest integer. I think at least it does on the interface. Maybe it internally doesn't, but who knows?
Who knows?
Speaking of which, there is something interesting about the Guitar Hero and Rock Band games. If you find some of the samples that they have been ripped from the games, they have also ripped the MIDI files that contain the notes that you play with the fake guitar. So obviously you can't get the melodies because they are simplified in order to work for the controller. But the interesting thing is that those MIDI files also contain tempo markers, and those poor developers have actually created tempo markers for each bar of the song by hand. So, and it slightly changes a decimal, for example, for rock songs which don't have a very steady BPM. But we're not talking about techno or electronic stuff. We're talking about rock stuff with actual drums. So each bar you see the decimal changing slightly because they wanted to keep it as accurate as possible. And it's awesome. If you load it in Reaper, it puts the stems exactly when you want them and the metronome.
Okay, they're available.
Yeah, you weren't supposed to know that, but yeah, there are.
Okay, they're hacked. That's
It's piracy. Don't do
all
that.
right. All right. Okay.
It's bad for you.
I see.
The thing that
by
no
the
one
way, I
talks
have a
about,
disc
but
of the
everyone
game and
does.
I have ripped it from the actual game, the disc. I have the Guitar Hero Metallica disc.
Okay.
So please buy the game so you can rip it legally, but don't upload the files. We don't condone piracy in here.
Yes. Okay. So.
Another digression.
At some point, I'm gonna expand on this and include all the different names that Chris used for the sort of the acronyms for them for the different tempos. And what would be really, really cool that I'm probably I don't know if I'm going to do it, but there are sites that have all the tempos or most tempos for most songs ever made. Maybe do a web scraping so you can get it. As you pick a tempo, you get a list of well-known songs in that tempo. That would be cool.
That would be cool.
Yeah, I posted it on the. I posted the more detailed guide on the chat.
Mm-hmm.
Do these decimals, are the decimals the same? Like, can we compare the one I sent with the one you made? For example, the 65 one? No. The 100, which one do you have open right now?
Give me for
101. Okay. Let's, oh, it's not in the list. What if you pick 102? Oh wait, it's rounding out. No.
Yeah, Chris is using like integers.
Yeah, can you see the one I posted in the link? Can you open it on my browser? The nodal tempo guide.
Ooh. Oh yeah, this one.
Can you pick one of the values on your plugin and see if the decimals are the same? For example, the 92 one. If it goes to 91 point.
109.59.
Oh, okay.
Isn't that the one I got up? 109. No, 109.
109.3. And
329. 590.
it's different.
Yes.
We found a bug.
Definitely. Let's see if
we choose a different one.
Yeah.
So what do you think is happening here? Is it a different algorithm?
Possibly.
Or maybe Chris is wrong.
Possibly, or quite possibly I'm wrong. Let's see if I... By the way, as a side note, this is the silent treatment algorithm. So it works this way. As the RMS level goes to a certain point, it drops slowly in level.
Oh, nice.
That was a digression. And logger. Where is Air Windows?
No, there it is, the first one.
First one. So the first thing I did was plot the tempos that Chris had picked. Say what?
This is hilarious. Continue.
Yeah. So this is the tempos that Chris had picked out from songs, like hit songs, well-known hit songs. Like
you can scroll down on this website to see what he used.
So I plotted those, and I used the find the curve finder or something, curvefinder.com or curvefitting.com. and put those in, and it came up. There was a bit of handstanding, you call it, Leandro, to actually make the formula work. But this was the formula that I came up with. So
I used to have a professor in
pi.
college that used to talk about the fat point theorem. Just make the points fatter. The curve will fit.
So this is the curve that I came. Oh, not this one. Sorry, this is a different one. It's slightly different, but this one was a bit. Wait a minute. It's coming back to me now. I made a curve and Chris made Chris made a formula. I made a formula, and these are the two different ones. It's coming back to me now, and you can see they're slightly different.
Yeah.
And in my opinion, mine fits better. But there you go.
What is the x-axis? The y-axis is BPM. What is the x-axis?
That's the formula.
Oh.
So as Chris described it, he describes it very well in the video, where he is rolling. He has I think it's paper roll of some sort of toilet paper roll, sort of the base of the toilet paper, or sort of a paper tube, and he's rolling a paper around it, and as sort of the tempos line up in a certain way.
It's getting more ridiculous as we describe.
Yeah, this is super nerdy. I love it.
Yeah, it's what we're looking for. Yeah,
and also one of the bases of this is I've nerded off on this. There's an economist and trader called Martin Armstrong who found a formula for market moves that's based on pi, and I haven't. So the formula itself is secret, but he sort of describes it and he talks about it a bit, and it's based on pi's and how everything is cyclical. So you can divide a day with a pi, or you can divide a year in pi, or a season in pi, and as you do that, you get to certain. Anyway, so that's a whole different science. But I like nerding off on that stuff as well. But this is somewhat the idea behind that is that as you go down in tempo, at some point you're going to reach where a beat is 24 hours long as you follow this curve along. And I don't know if that will interject with Martin Armstrong's formula. I have no idea, but you could divide the day and night, or whatever. So this is me nerding off on tempos. Thank you.
Lovely. I like it a lot.
Tip the
Amazing.
All right. So I guess, is this all from you, or do you have extra stuff to share?
This was what I had to share today.
Okay.
Okay, can I show something very final, just a few seconds?
Yes, go for it.
I have a suggestion on what we could do in a future live stream. Not necessarily the study group. We could do like a separate day for it. So this is the signal state. I have talked about it before. I turned off the music because it may be copyrighted. So this is a video game, a puzzle game, in fact, that we could solve together. I haven't finished it, and there are some parts that are very hard, but we can do it like one level at a time. Here are the levels. I'm gonna load the random level. So what is this? This is a post-apocalyptic modular puzzle game where you create a modular synth to save the world. But the thing is that the interesting thing about this, and the difficult thing about this, is that it's less about making music and more about getting into the more nitty-gritty electronics part of creating a modular system. So, for example, this is one of the easy levels. All you have to do is connect the source to a VCA. It teaches you how the VCA works. So you connect the output to the output, but then you use the second source to modulate the control voltage of the VCA. And if we do it wrongly, you play this. So the blue is what you're supposed to get, and the red line is the wrong one. You can get it from the sound effects as well. You can do it faster. But if you connect I have to stop playback. When you connect the right modules the right way, you solve the puzzle.
I am in. I like this a lot.
Yes, and in the future levels, it's getting much more complicated. But we're gonna learn a lot about logic gates because it has a lot of stuff that I don't quite get, and we can explore them together because there are some parts that are very common in electronics. In fact, I have this behemoth of a book. Oh God. Do you see this monster?
Ever so slightly, because you are just a tiny window in the corner.
Oh, it's off focus. Okay. No, it's in Greek. You can't get it. It's called digital drawing, and it's a huge book. My brother actually got this from his informatics school, and it has theory on logic gates like the AND, the NOT, the XOR. But it's very well written, and I plan to study this one because I want to learn how to use these things in modular synthesis. And the cool thing about the signal state, one last thing and I'll wrap up, is that it has a sandbox mode. It was recently added, and you can create everything you want, and you can actually make music with this one. You can see Ben Jordan has made 2 videos about it. The first is a review, and the second is a stream where he showcases the sandbox mode. But for the main game, he said that he loved it, but it broke his brain in that he made him think about his modular synth in a very different way, because it's in a very educational game. It helps you understand the logic and the sequencing and the voltages behind it all. So you have to calculate the steps, the voltage, you have to do basic math and then more complicated math using only modules and cables. So are you guys game?
I am in. I like that.
Okay. We could do like a separate stream if you don't want to do it in the study group, like a different day. Or do you want to do it in the study group?
We'll figure it out. We'll figure it out.
Like the Euler ones. We solve one Euler, we solve one signal state.
Maybe.
We can do it this way.
How did the Euler go? Did it compile?
Yeah, that is the last thing, right? Okay, so it's my turn. I'm going to share this screen. And what are your bets? Do you think that we solved the problem? Do you think that the brute force approach is good enough to find the 10,000th and first prime number, or do you think that we need to be smarter than brute force?
I think the brute force will work. I mean, it always works at some point if you're patient.
If you're patient, I think that it does not work. I think that not even in C++ this will have finished. So, drum roll.
You're free to scream if you can.
And, oh, look at that, look at that.
Oh,
it actually finished. It actually finished. Now let's check if it is the right number, though.
Uh-huh. Oh, yeah, we should check out if it's a prime number.
We should check if it is, yeah, we could check that this is actually a prime number, but let's not. And also, we need to look at the ChatGPT answer. Maybe next time. We have been going for a while now. Would you look at that? The brute force approach is good enough.
Oh my God,
right.
Amazing.
How long did it take to compile?
Well, I should have timed it, but I didn't, so I don't have the answer to your question.
All right.
So it used all the possible combinations?
Yeah, well, my solution, as you saw, is radically straightforward. As in, we start with the number 2 and we count up. And then for each number that we are attempting, we go from 2 up, and we check, does the number divide evenly? And that's that. We are not even smart enough. I mean, for instance, this comparison is silly because if no numbers below the square root of the potential or of the prime candidate, if no numbers below the square root of the prime candidate divided the prime candidate evenly, then we can tell that it's a prime. We don't have to go all the way up. We don't have to go all the way up to the prime candidate. We could have gone just to the square root of the prime candidate. So that's just, if you stare at it for 5 minutes, you will realize that what I'm talking about makes sense. But I didn't do anything clever, no mathematics involved. Well, pretty much no mathematics involved. No clever algorithms about how prime numbers behave. Just basically the definition of a prime number. And it was able to find the right answer. So yeah, good enough for me. Now let's take a look at what ChatGPT did for a second. Boop. And boop.
It's longer.
It is longer. And I can already kind of tell why. But let's not get ahead of ourselves.
Oh, it's not using the brute force, right?
It's not using the brute force. So to begin with, it is doing the thing that it always does. It is extracting auxiliary functions, and I'm okay with that. But it has some silly cases here that are probably here for performance. Well, to begin with, this is probably not for performance, it's for completeness, because it's defining the is prime function in a way that works even for negative numbers. So who would ask if -5 is prime? Silly question to ask. But they are guarding against that here. And this is another comparison, so one could argue that this makes things slower. Anyhow, this is just silly, because if the number is less than or equal to 1, it's going to return false. If it is less than or equal to 3, it's only going to match the number 2 and the number 3. So it's optimizing for these two numbers, but this question is only going to be asked for the number 2 and the number 3 once. What a silly optimization. Maybe it's significant if you are comparing, if you're testing the primeness of a list of numbers, a list of random numbers, say. But anyway, silly optimization. Then it's dividing by 2 and dividing by 3 explicitly. This is something called loop unrolling, because here is a loop, right? Here is a loop that checks essentially the same. You can see a similarity between this and that. But it is explicitly dividing by 2 and 3 beforehand as a way of perhaps making things faster. I'm very curious to know if it makes anything faster in reality, because it's making the code longer and therefore more complicated. Here I am spending minutes talking about this, and everyone who reads the code needs to think about this. So I wonder if it pays off to actually do this. And then there is the loop that it is actually using the clever notion that I was talking about. You don't have to check all the way up to a number. You can just check to the square root of it, or conversely, you can square the number that you're using to test. So this comparison, instead of taking the square root of n, it's taking the square of I, which boils down to the same thing. But it's only checking up to the square root, which is a lot less comparisons that we made in our code. So this trick here saves a lot of comparisons, and it probably makes the program significantly faster. Anyhow, then it is checking if the number divides evenly, and it's also checking if the next the next even number divides evenly. Not sure I get this part. And then I guess it's a similar algorithm where if you found anything to prove that the thing is not prime, then return false. Otherwise, by default, return true. Okay, and then find the nth prime. Again, it's extracted as a function, and you can ask about any nth prime instead of having to come here and change this. And okay, you need to have a base case here. Not quite. I think it could be done with this loop, so this seems silly to me. And then it is just counting up in pretty much the same way we did. Oh, it's also doing something that makes everything a lot faster. Instead of incrementing numbers one by one, like we did with the prime candidate, we just plus the prime candidate here. Well, that's silly because every even number is divisible by 2. So you could, instead of doing this, you could have done that. And it would potentially make things faster because you're skipping a little bit of code that would reach this part and then find that the number is divisible by 2. So it would reduce the number of mod operations. Yeah, it's a low-hanging fruit in terms of optimizations. I like this one. And then this is just driving the rest of the auxiliary functions. So overall, not bad. Let's see if it works. And it didn't apply any, I would say, clever optimizations. So I wonder if it will answer in like almost no time at all, because that would surprise me.
Yeah, you should run both and time them.
Well, I'm gonna time the second one.
Mm-hmm.
And yeah, it finished very fast. And it got the right answer. And it finished in, yeah, like almost no time at all. Half a second.
How much is the streaming and Skype using resources and throttling?
That is a good question that I would also like to answer. So I'm going to open Activity Monitor and I am going to view, no, I'm going to window the CPU history and I'm going to view the GPU history. I'm going to close this one because I don't need it. So now we have graphs of what's going on. So this is ChatGPT getting the answer in almost no time. And then the humans are going to struggle more. And as I start this, oh, it actually doesn't take a lot. It takes 4 seconds.
Cool.
Did I switch to another
Sweet.
window in less than 4 seconds? Was I that impatient?
Wow.
I don't know, but it barely registers in any of these meters. Huh, not bad. I'll take it.
Wow.
And I would also argue that if you are not doing this frequently enough, I think that perhaps not having the optimizations is okay. One wouldn't have to think for 5 minutes to convince oneself that... Oneself? Is that even a word? To convince themselves that you can do the square root trick or the squaring trick, however you want to think about it. This squaring trick here, and this is not too hard to convince yourself of, but still. And there is a nice comment here explaining that. Anyway, yeah, we all are winners today, both humans and ChatGPT. I'm looking forward for the Project Euler problem in which brute force will not suffice, and then I will have homework and I will have to figure out a faster way of doing it. All right.
Sweet.
All right.
So that's that for today. How about we wrap this up?
Yep. It
Absolutely.
was super fun.
All right. Okay.
We're back on track.
So yes, we had.
We went to the dark side.
We had a little break and we had a lot of fun, and we finally had an IRL, an in real life meeting of the study group. I met Bo in person in Sweden. It was a lot of fun.
You can come to Greece next year.
Maybe I will.
Huh.
Maybe we'll have a meeting and all of us will go somewhere.
Yeah.
That'd be fun.
Yeah.
Microsoft.
Please do.
All right. Okay. So I want to thank lots of people. Cwits, who is no longer with us, but still lives in our hearts, and Fotis and Bo for joining us on the meetings.
That was dark.
And I also want to thank people here on the chat. So Theo, for instance, I want to thank Theo for being awesome all around. And Theo is saying that the ChatGPT is prime, thus I plus equals 6, which should also make it faster, just saying. Now I'm curious. What is this? Ah, interesting. And that's why it has to check that. Right? No, I don't see it. Why is it skipping in steps of 6? Huh. I don't get it. Do you get it, Tail? It's getting the right answer, so it must be right. I just don't understand why this is an okay thing to do. Steps of 6. Seems arbitrary. Anyhow, thank you to Ben for showing up. Long time no see. It's great to have you here. And Matthew, perhaps next time you want to join the call and hold yourself accountable to us. It's the best way of getting stuff done. And Ethan, thanks for stopping by. And everyone else who were watching this. Words, complicated stuff. It's great that you are watching this, and I appreciate you being here. Looking forward for next time. Have a good one. Bye-bye, everyone.
Thank you, everyone. Bye.
Take care. Bye.
Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And so we'll all